Here we go. Okay, so we'll pick up with vertex form and just quickly review. Yesterday we went over the first case. If A is 1 and K is 0, so remember A is the coefficient out front, and K is what is the constant we add at the end, which is the y coordinate of our vertex. These are fairly easy to convert from standard form to vertex form. For example, if we have y equals x squared plus 2x plus 1, all we really have to do is factor this because it's already a perfect square. Y equals, what are my perfect square factors here?
Plus 1 squared.
Yeah. X plus 1 squared. And so this is vertex form. It's just that A is 1, so I don't have to write it. K is 0, so I don't have to write it. Any questions about case 1? You guys did these on your homework. Alright, so let's look at a little bit slightly more complicated case.
Why very more common?
And what I want to do is start actually with the vertex form and convert to standard form so we see what these look like. So for case 2, we're still going to keep A as 1, but now let's say K is not equal to 0. So we have some other number here.
I think I figured out how to do this last night, but I
Cool.
don't know for sure.
Yeah, so this is completing the square. What we're going to do to convert into vertex form is complete the square. You guys have done completing the square. So hopefully this process will feel familiar. But it will look a little bit different. And the reason it will look different is because we have y equals instead of 0 equals. With completing the square, you have 0 equals and you're trying to find the zeros. So for case number 2, let's just pick a random vertex form. If A is 1, I'm just going to have x plus something squared, or x minus something squared. So let's just say x plus 3 for now, squared. And then let's pick a k. Let's say k is 1. Can you convert this to standard form?
They just have to.
So we're going to just expand what's in the parentheses here. Expand our perfect square, which will give us x squared plus
3x plus
6x
plus 6x plus
9
9
plus 1.
plus 1. So if I combine like terms, plus 10. This is my standard form. These are the same parabola. If I were to graph this and graph this, I would get the same thing. I can sort of prove that to myself by using my vertex formula. Negative b over 2a would be negative 6 over 2, which would be negative 3. And then up here, remember, this is a negative 3 because h is already negative in the equation. So I can kind of see that these are the same, and if I were to actually graph them, I promise you they would look the same. So for case 2, the standard form is going to look like any parabola that's not a perfect square, but it does not have an a out front here. Okay, so let's choose one to do, and we'll convert this time from standard form to vertex form. Let me see what I have over here. So how about y equals x squared minus 8x plus 17. Here's standard form. we want to go to vertex form. Now, there's a couple ways you can look at this. What I like to do is kind of put parentheses around my first two terms, because that just helps me focus in on those first two terms. Another way to do this, I think the way Gary teaches this, x squared minus 8x plus 17, he teaches just put a line right there. So you're keeping your 17 off to the side. Either way, what we want to do is look at this and pretend we're completing the square. Well, we actually are going to complete the square. So if we're going to complete the square, we could rewrite this as x squared minus 8x plus something,
16.
which will be whatever I do to complete the square, plus 17 minus something.
Wait, what?
So if I add something to my equation,
Do you have to add
I've
it to
changed the equation.
No, but if you add it to one side, don't you have to add it to the other
So I could add it to the other side. But I want y alone over on the other side, right?
Oh, no,
So
sorry,
if
I was
I
thinking
add something here,
You just minus it off.
that's the same thing as subtracting it here. So essentially what I'm doing is I'm adding 0. But in order to add 0, I'm going to add 3 here and subtract 3 here. Or I'm going to add 5 here and subtract 5 here. Plus 5 minus 5 is 0. If I add 0, I don't change the equation. Okay. So what do I add here to complete the square? Right, half of 8 of negative 8 is negative 4 squared is 16. And then I have to subtract 16 here. So this setup step is really key.
Can I have y equals x?
Now I can
plus
factor my perfect square.
X plus 4 squared plus 1.
Okay, now remember when I took half of negative 8, I had
minus 4 squared.
Yes, because it's negative 8.
x minus 4 squared. That's this, right? The parentheses turns into this. And then I have plus 17 minus 16. So I have plus 1. So this is my second case of vertex form. I have some sort of a k out here. Any questions about that?
So that's your final answer.
So this is my vertex form, yeah. My vertex would be 4, 1. If I were to graph that.
4, 1.
Alright. Let's look at the third case. We're going to kind of have 4 cases total. So case number 3, this is going to get a little bit trickier. What if A is greater than 1 and K is not equal to 0? Or just in general, what if A is greater than 1?
Then you have to divide it.
So let's look first at a vertex form, convert it to standard, and then we'll switch. So if I have vertex form, this would look something like maybe 2 y equals 2 x, let's say x plus 2 squared, and then let's just do plus 2 again. I have a lot of 2's. So now I have an a that's bigger than 1. So to convert this to standard form, I'm just going to follow order of operations. I'm going to start with parentheses, exponents, then I'm going to do my multiplication, and then the last thing I'll do is my addition. So starting with my parentheses and exponents, what is x plus 2 squared?
X plus.
I'm going to rewrite y equals
You just do
2.
the same thing, but you don't put parentheses or a.
So now I have x squared, that's x times x. And I'm going to take 2x and double it, so plus 4x. And I'm going to take 2 and square it, plus 4. So this is equal to this, plus 2. Now I have to remember what property?
Distributive.
Distributive, right? Distributive property, so I have y equals 2x squared plus, how many x in the middle?
8x.
8x.
Also x.
But shouldn't you
Eight.
have to
Don't
add,
forget your plus 2.
shouldn't you have to subtract a 4 from the other side? From the 2?
When I'm going the other way, right, when I have to complete the square, all I did from this step to this step was expand this. X plus 2 squared, so x plus 2 times x plus 2, that's x plus 2 squared. So I'm going to do first, which is x squared, outside 2x, inside 2x, last.
So why did you use
And then
completing
make
the
it-
square for the other one and not for this one?
We're going to use completing the square when we're going from standard form to vertex form.